Hey friends, what we're going to look at in this lesson is increasing and decreasing functions. And in this one, more specifically, we're just going to look at it visually. And then in the next lesson, what we'll look at is how to maybe algebraically figure out if something's increasing or decreasing. But for now, let's just stick to what does this look like visually. So here's some random looking function. And what I'm going to do is I'm going to look at this in terms of breaking it up into certain little mini intervals. So I'm going to break it up at -5/2 and at 3/4. And so what you can see there is I chose the two spots where one is a maximum and one is a minimum. So those are the three intervals. So from -infinity to -5/2. So this little region right here. What I want to notice at this point is the slopes of the tangent lines. So f prime, the slopes of the tangent lines would all be positive. So if I drew tangent lines anywhere along here, do you see what those tangent lines are doing? They're all positive, okay? So if I was describing this section right here, I would say that this section is increasing because the slopes of the tangent lines have positive slopes. Now I'm going to look at the next region. So the next region is here between -5/2 and 3/4. So again, if I think of the slopes of the tangent lines, again, I draw in some tangent lines. And now what I want to notice is the slopes of the tangent lines at these moments are all negative. So the derivative is less than 0. All the tangent lines have negative slopes. What does that tell me about my function? It tells me that my function is decreasing. We go to the third interval, greater than 3/4, right there. Well, guess what? I draw in some more tangent lines, right? It's all about the tangent lines today. Draw in some more tangent lines, and the slopes of all my tangent lines will be positive. So that means the derivative is greater than 0, and all of the tangent lines have positive slopes. So we just figured out something really, really important. What we just figured out is if our slopes of our tangent lines are positive, the function is increasing, meaning the y values are getting larger. If a function is decreasing, like it is here in the second interval, that's when our derivative is less than 0 and our y values are getting smaller. We're decreasing, right? And then again, in our third interval, our derivative was greater than 0, so the function was increasing, and the y values are getting larger. So we can see why taking the derivative now is going to help us figure out if a function is increasing or decreasing when we don't have the graph. Okay, but I missed something here. I talked about these three intervals, but what about at where I decided to split those intervals up? Right here and right here. Well, if I draw in the tangent line there, the tangent line will be horizontal, which means the slope of a horizontal line is 0. That's when the derivative is equal to 0, right? A tangent line is the slope. So when the derivative is equal to 0, the tangent line is horizontal. I don't have enough room to squeak it in there. And same thing here, the tangent line is horizontal. So what that tells me is the function is neither increasing nor decreasing. What's going on? Well, if my function's neither increasing nor decreasing, guess what? We're going to help us find our max and our min. All right, so here it is. So visually, when I'm looking at a graph, finding the increasing and decreasing is easy. So in general, if the derivative is less than 0 on an interval, the function is decreasing. If the function derivative is greater than 0, then the original function is increasing. And if the derivative is equal to 0, that means the function is neither increasing nor decreasing. Now, this may give us a max or a min, may give max or min. We'll talk a little bit more about that in the next video. But for now, that's how I want you to think of these things. So here, let's do one more. So state the intervals of increase and decrease for the function below. Okay, so what I'm going to do is I'm going to go and look for where my tangent lines are 0. That's right there. That tells me the derivative at that point is equal to 0. So where am I decreasing? Well, visually, I can tell where I'm decreasing. I'm decreasing right in here, aren't I? So I'm decreasing between 0 and 2. Notice I don't include 0 and I don't include 2 because we're neither increasing nor decreasing. Okay, where am I increasing? Well, I'm increasing right here. So that's negative infinity to 0. And I'm also increasing right here, comma, 2 to infinity. Now, again, how do I know that if I'm doing this algebraically? What this means here is my derivative is less than 0. And I'm increasing. What that tells me is my derivative is greater than 0. Now, notice here, we've got a max. That max is when the derivative is equal to 0. Down here, we have a min. But my friends, this minimum that I have right here, my derivative does not exist at that moment. So something else for us to think about coming up here is a max and a min. A max or a min occurs when the derivative is equal to 0 or possibly when the derivative does not exist. All right, that's going to be really, really important in the next lesson. Okay, see you again.